Hey guys, welcome back to another video on process mining. A few months before, I have made a video on how to analyze a lead to convert process using Celonis Snap. I've explained how to load data, build process analysis, and how to get insights from the analysis built within the tool. I've pasted that video link in the description for your reference. As part of the previous video, I mentioned that the analysis built on process mining tool is hard and time consuming to replicate in a traditional BI tools like Excel, SQL, or Power BI without a process mining add-in. I also mentioned that if people are interested, I said I'll make another video on it. This video is all about that, why it is hard and time consuming to perform process analysis without a process mining tool. In some cases, it is impossible to replicate. Let's dive into the details now. Let's get started. Yeah. So, if you could see my screen, you can see that this is the quick process explorer we built using the data that we uploaded to Celonis Snap. The data is here, which I'll show you. So this is the data. This is the event log which we used, which we loaded into Celonis Snap and built this analysis. Yeah. So this is a process explorer, and we also built a variant explorer, and we also built a case explorer, but we also built some additional KPI dashboard similar to Power BI. But in today's video, I will explain what is a process explorer, what actually it says, and what is a variant explorer, what actually it says. Similarly, what is a case explorer? And also, we will try and build this process explorer in Excel, and we can look into the complexity we would come across, and that would help us to understand why we require a process mining tool. Okay, so now to explain process explorer as a first stand, let me take an example. Yeah, so let's say a simple process is there. It has multiple activities, and these are the different flows of that activities. Yeah. So now the process explorer is something that will tell the shortest path that has been taken by the maximum activity in a process. Okay, what do I mean by that? So here you can see this is one path: activity 1, activity 2, activity 4, and activity 5. This one. And this is another one: activity 1, activity 3, activity 4, and activity 5 is another path. And activity 1, activity 3, and activity 5 is another path. So now here the shortest path, how would you find that? The shortest path is the total time taken, right? Okay, so here we can say the first path is taking 5 hours, 1 plus 2 plus 2. The second path is taking 1 plus 1 plus 2, which is 4 hours. The third part is taking only 2 hours, 1 plus 1. So the lowest time is 2 hours, but it has only 3 activities: activity 1, 3, and 5. But the other two path has 4 activities. Yeah. But we have to take the maximum number of activity that we can cover in the process explorer to explain the process explorer, and the lowest time. So in that case, the second path, which is activity 1, activity 3, activity 4, and activity 5, is the shortest path. And that's what would come as a happy path, in a process explorer as a opening standpoint. Okay, so this what would give. So if we have lots and lots of uh, activity and multiple, say this is one case I'm talking about. Sorry, 3 cases I'm talking about. If there are multiple cases, so there'll be multiple variations, multiple different paths. Okay, they'll be taken. But what we are after is in Process Explorer, it will tell you the path that has the least amount of time that covers the maximum number of activity in the process, so that we can see which activity performs the most in the process, and but the overall end-to-end process takes the lowest time, and that is called as Process Explorer. And Variant Explorer, on the other hand, so this is giving you all the different variant in the process. So what do I mean by that? So if you look at this, there are 5 activities: activity 1, 2, 3, 4, and 5. But how many variants are there? The first path is there, second path is there, third path is there. So those are the variant. So the Variant Explorer will give you an analysis of different variance, okay, in the process. So in this case, okay, in this particular example, so there are 8 different variants. And the lowest number of variants means the process more standardized. So that's what many companies go for. Okay, they want to minimize the number of variants so that every time a process happens, okay, it is the same, so that the final outcome as an output is the same. And that's what every company wants to achieve. And finally, what is a case explorer is you can go into single case and you can select that and you can look at, okay, what are the different activities that has performed, what time it has performed, who has performed it, and those are the uh, details you'll get in a case explorer. So if you want to analyze a single case uh, from end to end, you can use case explorer. So now let's see, okay, let's try and build this process explorer in Excel. Okay, probably not process explorer as a first standpoint because this is a little bit more complicated, but let's try and build the variant explorer in Excel. So I have got this data, which is what I uploaded, okay, in Celonis Snap. Now I'm going to slice and dice this, okay, to build a simple variant explorer similar to this one. And I'll explain you and I'll uh, uh, match it side by side so that you get an idea. Yeah. So this is the first variant we have taken. So now let's see here. So this one, we can use simple pivot tables to build it. What I've done is I've created this pivot table. What I've done is each case, what are the list of activities that has performed and what are the time it has performed. And what I've done is separated that case separately. Okay, so case one, this is the case one, which is the user one uh, going through the starting of the process till end of the process. Likewise, user 2, user 3, user 4 till user 10. So these are we have 10 cases. So let's not confuse user with the actual user. Okay, but I'm just for simplicity, I'm taking user as a case ID. Yeah. This is one case. This is a website entry. Someone comes and visit the homepage of a website till they buy something within the website. That the lead to conversion process. So let's say the first user come in and the user one has a user ID called user one, and that is taken as a unique ID for that particular user. So we have 10 different different cases, but how many variants are there? So I have to build this pivot and I have to separate all this out to identify the variant. I have to analyze like this. So you see, this is a unique variant. Visit homepage, click sign up and close session, which is performed only by user one. So this is another unique variant, which is performed by user two. But if you see this third one, okay, user three and user four are performing the same, process. So we can combine these two as one single variant, which is variant three. We can see landing page, visit landing page, visit how it works, visit product, click sign up, select product A, click buy now, complete payment and close session. And the same list of activity is happening in a sequence in both by both user 3 and user 4. And that's why we consider as a variant 3. Likewise, variant 4, variant 5, and variant 6 is performed by user 7 and 8. And there is a variant 7, variant 8. So if you come here, okay, so and see, we can see the total number of variants is 8. Even though there are 10 different cases, there are 8 variants performed by 10 different cases. That is 10 different people who come into the website. And it matches to the number of variants here. You see, to identify that variant here, how difficult it is. Imagine if you have a process that has, I work with processes that has nearly 1 million cases. If you have to find the different variant in 1 million cases, you cannot keep drawing like this. It doesn't work, yeah. And that's where the process mining tool, with very simple steps, it produces all the variant for you. So as I showed you, this is the first variant. Visit landing page, click sign up, visit product, how it works. Why this is coming as the first variant is because you can see this variant has occurred the maximum number of time. So if you notice, this has 8 number of activities, uh, and if you see, it has happened twice. So I think this is similar to this within language. No, I think I'm wrong. Yeah. So the first variant, how it is showing here is it's showing the first activity is visit landing page. That's what it's showing here. That what it does is it compares to all the cases. It checks for the first activity. So by variant one, the first activity is visit homepage. But how many other places the first activity is visit homepage? Nowhere. So if you see variant 2, 3, 4, 5, 6, and 7 and 8, the first activity is visit landing page. And that's what is taken as the first activity here. And likewise, if you see click sign up, so it happens here in this as a second activity. Doesn't happen here, doesn't happen here, doesn't happen here. But it happens here 4, 5, 6, 7. Yeah. So basically it happens in 1, 2, 3, 4, 5 variants. But the other 3 variants, something else is happening. So the maximum times that particular activity happens in different variants, taking as the second variant. That is click sign up. Third one, likewise, visit product. So here it doesn't happen, but it happens in this variant 1, 2, 3, 4, 5, 6, 7. So basically, in 7 variant, okay, visit product. No, I would say 6 variant, okay, because I can't counted this twice. So, and how it works is the fourth. How it works, this is the fourth variant. It happens here, and it happens here 2, 3, 4. So it happens in 4 different variants 1, 2, 3, 4. Yeah, and that's why it is taken. So, and like for example, if you see click the second one, you can see a different variant. This variant would match to one of the variants here. So if you see the first variant, visit landing page, click sign up, visit product, how it works, select product C. So let's see where is that. Okay, so visit landing page, click sign up, visit product, visit how it works, select product C, click buy now, complete payment, and close the session. So this is the first output it shows. If you click on the second one, so visit landing page, how it works, visit product, click sign up. Visit landing page, how it works, click product, visit product, click sign up. Select product A. So this one, click buy now, complete payment, and close the session. So this is the second variant it shows. If you look at the third variant, we can see visit homepage, click sign up, and close. This is the third variant. Visit homepage, click sign up, and close session. So this is how the variant explorer is done. It is very useful for standardizing a process. But to build this on Excel, it's going to be extremely difficult looking from the data. I hope you got the point. Yeah. So that's the first one I want to explain. The second one is the process explorer. So if you see here, so as I said, the process explorer, when I explained, it is the lowest time taken by the maximum number of activities. So process explorer is like, let's say you're taking a starting point and you're going to an ending point, and there might be multiple different hops you might do, activity you have to pass through. So this would take the maximum number of activity you're passing through, but that takes the lowest amount of time in the overall journey. And that's what it does. Yeah. So here to check, okay, first we have to check which has the maximum number of activity, which variant. Yeah. So if you see, we can see the maximum number of activities happening in variant 3. That is this one, this one, this one, and this one. Right. So others we can ignore because it doesn't cover all the activities. Yeah. Maximum number of activities. Now the second thing you have to look at which has the lowest time. So if I take the time, okay, which is the ending minus the starting, so this takes 0.99 uh, 0.99 minutes. Let's take 0.99 minutes. Okay, these two are the same. compared to this, and this. Okay, these two are the same, and which is the lowest. So now these two are lowest. Now how it is going to show which is the happy path? Okay, so that's where this analysis even more in depth. The way it does is if you see in these three, they have the visit landing page as the first one. This one, how it works. Third one is visit product, okay, which is the same in all the three. And fourth is click sign up. So here, click sign up is coming up here, right? Okay, the reason why it comes up is, okay, it is there in maximum number of cases. So this fourth activity is click sign up. Here, the fourth activity is how it works. This fourth activity happens only in this particular case, but here the fourth activity is happening in more than one case. So it consider that as the high priority to show as the happy path, and that's why it showed this as the first happy path, okay, in the process explorer. Now this can be expanded further, so that would show you other deviations. Likewise, you can expand it further, okay, to analyze it better. Yeah. But to build something similar in Excel, think about it. How hard is it? So in process mining tool, all I've done is build this data model. Anyways, even for Excel, you have to build this data model using a data model. And here, if I load it, this is automatically done for me. Yeah. This analysis is automatically done for me. But here, if I have to do, look at the complexity I have to face. Okay. I hope that explains how difficult it is to build it in Excel, or if you're going to build this in Power BI or even a SQL, it's going to be equally difficult. And if you're looking at like 500,000 cases or 1,000,000 cases, and looking at some 50, 60 activities for a process, it is not possible to do it in Excel or even Power BI or SQL. Power BI, probably with the help of a process mining add-in, you can do it, okay, but it will be still limited to the data you have. But you have to use a tool like Celonis or UiPath process mining. I think it used to be called as process goal before. So you need a tool like that, okay, for you to perform the process mining analysis. Yeah. Some more example I can provide is let's say as an example, so you want to look at the process without this activity, yeah, select product A. So here, very simply, I can say without this activity, it shows you the process and how much time it takes, what are the different activity it passes through. But if I want to do the same thing here, the way I can do it is, let's say without product A, there are total number of 10 cases. 3 cases as product A, that is 10 minus 3, that is 7. And that's what is showing here, 7 cases without product A. So this is, first step is kind of, we can still do it. But imagine, okay, if I'm going to add another complexity to it, I want to find a process without this particular activity product A, and also want to see the process only with the activity complete payment. So this is only 2 cases, yeah. But here, how will you find it? So without the activity product A, you can say 10 minus 3, that is 7. Now, if you want to find within that 7, how many has complete payment? So we can see 5 activities has complete payment. 5 cases has complete payment. But how can we find it? 7 minus 5 we cannot do. The way you can do it is, you can go here, again check, okay, so first one without product A. So these 2 are ignored. So you can look at this, and these 2, yeah. So those are the ones that are there, okay, without product A. But now if you want to look at, okay, without with only payment, so these 2 doesn't have payment, these 2 has payment, and these 2 doesn't have payment. So you can say two different cases has without product A as an activity, with complete payment as an activity. So this is easily findable here, but to get it here, it's going to be difficult. If you think about, if you have 1,000,000 cases, how are you going to find out? Here in few clicks, you can find out, and you can add another complexity to it also. You can also see, here, I think I don't have any more variations. Everything has two. But you can, let's say, if there is another variation, you can, let's say, if this is three, and you can see which one has, so let's say if it is one, which particular path has this alone. You can just select with this activity alone. Then you can clearly see, okay, which process is it. And if you want to see in this combination, what are the cases, you can go to the cases. These two are the cases that has the activity product A, and that doesn't have the activity product A. So select product A, activity, complete payment is there. These two cases has. You can go to the details and see. You click on that, you can see it has no select product A, but it has complete payment. And you can see, okay, who has done it. And that's the level of analysis you can do in a process mining tool. But doing this in an Excel, I don't know. Okay, so how someone can perform that level of analysis is going to be very, very difficult. Yeah. I'm not saying no, okay, but the time taken and the complexity is going to be extremely difficult, and it is not practical or pragmatic to do it in Excel or a Power BI or a SQL. I hope I have made justice to what I mentioned in my previous video, explaining you the complexity. If you have to do the same thing in Excel, if you're interested to discuss more on this area, or if you want to know, okay, what you need to learn, how you can get upskilled on this, so I have a link in my description that opens up a free one-on-one discussion with me, where you can connect with me. Basically, we can have a chat on what you do and what is your interest in process mining, and I can suggest you how you can upskill yourself. Yeah, I think that's it for the video. If you like it, click like and subscribe to my channel, and also share it with your friends who are interested in this area of work. Yeah. Thanks a lot, guys. You have a good day. I will soon come up with another video. If you also have any requests for any other video, please post it in the comment. I will try and make one soon. Yeah. Thanks a lot. Bye.